Share the screen. And there we go. So
You're
ready
running
to
a
start.
you're running a month behind, Wagner.
Sorry?
You're running a month behind.
It says May 2021.
Yeah. It's May. It says May 2021 on the presentation.
It's because the last one that was in May was already in June, right?
Nice.
Let's see if it fixed. There we go.
Yeah.
Thanks for that, Arun. All right, so let's start. Welcome everyone for ACSUG June 2021, not May. And today we're going to be talking about running logic apps on a container platform. As usual, before we start, let's just talk a little bit about who is ACSUG, right? So far, we call ourselves Auckland Connected Systems User Group, but there is a lot of talks internally now that we're doing all of this hybrid and virtual and be able to access the whole New Zealand. We are really tempted to change the name to Aotearoa Connected Systems User Group, so we can have a discussion about that later, or maybe put something for you guys to vote. What do you think? We have over 300 members. I think by now it's probably close to 500. We are the organizers of the Global Integration Bootcamp here in New Zealand since the inception. And our leadership team has 5 people. 3 of them are here today. Have Craig Hayden coming from Tauranga, Colin G-Graph that couldn't join us today, myself, calling from sunny Gleneaden. Alessandro that couldn't join us today because has working on another presentation, and Will that is joining us from the ferry. So Craig and Will, that's what I call commitment. And how can you help? Right, you can volunteer for a talk like Vinnie did before. You can suggest some topics. You can raise your hand to help with the organization. Between us 5, we always trying to get like new ideas and think about who are not the next speakers and things like that. So having more people to help with the organization is always useful, right? If you wanted, you can follow us on Twitter on ACSUG NZ, and I always mentioning ACSUG NZ when I put in anything related to the user groups there. So it's one way for you to find information. And if you wanted to see our past presentations, you can subscribe to our channel on YouTube. So the group, when it comes to 100 subscribers or more, we're going to be able to actually have YouTube/ACSUG channel. But for now, you can access on the bit.ly link that we have there. On today's show, we have running logic apps on a container platform that's brought to you by Vinnie James, which is one of the principal integration consultants at Theta. I think I've been working with Vinnie for 3 or 4 years with a break back and forth, and he has like a lot of experience on Azure in general, and spending a whole lot of time on the logic apps standard, and especially on containerization. So I think it's going to be a really interesting presentation. ACSUG Legends is not Craig joining us from the pub. I really wanted to talk about that, but I didn't know until now. The one is like, it's kind of a sad one, right? It was almost our first event outside Auckland, but we'll try to do that again in the near future. And so if you're interested to present, are you in Christchurch, in Tauranga, or whenever you are, if you wanted to present, let us know, and we can try to make it like a hybrid event on your location. Go in there, do the presentation in person, and then stream for the rest of the country. So that is me for now. I'll let Vinnie now share his screen.
Right. Thanks a lot for that, Wagner. All right. So some tasty looking
And
pizza.
Craig, stop showing food, man. I'm starting to get hungry.
I'm hungry already.
Yeah.
Right. All right. Okay. So thanks a lot, Wagner, and thanks a lot, everyone, for joining. I'll shortly start my presentation here. All right. Here we go. Thank you, organizers, for the opportunity to present here. And it's been a long time kind of dream that actually I should be starting presentations and sharing the community and things like that. Yeah, so today I got the opportunity, and thanks Wagner and the rest of the organizers for the opportunity. And yeah, so today we are going to talk about logic apps on containers. As a matter of fact, actually, not only logic apps, any Azure PaaS services, the list is growing. Actually, you can run most of the Azure integration PaaS services in container, and you can also manage it from Azure. I'm actually looking to do this session in kind of a three segments. I want to say why do we actually host Logic App into the container, and the benefits and the reasons behind it, and then actually obviously how can you actually do the containerization of the Logic App, and wherever you can host and how we can manage and things like that. And the last segment, I wanted to say what else, or what should and what can you do on top of not only putting it into the container, what else you should be doing to make sure that actually it is properly implemented, properly secured, and it's continuously improving, and things like that, right? So moving on to why. So why, so Logic Apps, as a kind of a small background, for those of you actually, if you don't really have any integration experience or any Azure integration experience, Logic App is actually a tool, one of the tools from Azure Integration Services that helps you to build the integration workflows, and it helps you to connect between systems to systems, and transfer and transform message from system A to system B. It is mostly, so far, it has been multi-tenant Azure managed service, which you can actually only run in Azure, and it is actually consumption based, and your development experience was actually on a portal and also on a Visual Studio Code environment. Like the recent developments are actually helping you to do the development from the portal, like from Visual Studio Code as well. But now, with the recent developments, actually, Azure has launched Logic Apps Standard, which is a single tenant application. You can actually run a single tenant application on an Azure App Service plan, or your own choice of actually container platform. If you're running your container platform on premises or any other cloud services, you can put your Logic App as well into that, and you can also actually manage the container workload you're developing on Logic Apps, right? Why do you want to do it? Why do you want to actually go for container platform for Logic App? So say, for example, you're already running all of your apps and services on Kubernetes, and you want to extend those processes and controls to all of your Azure PaaS services as well, right? So you have other workloads running on your container, you have a mature container platform, and you are using Azure services such as Logic Apps, Azure Function App, even Grid API management on the Azure as an Azure PaaS service. But you want to extend that, you can actually, now you can do it. You can actually put all your services together into a single Kubernetes container platform, and you can manage it. And so the second option would be you want to use Logic App as your integration platform, and but you need very fine-grained networking and the flexibility on the compute and everything. But you don't want to use the integration service environment because it's expensive, and it is still on the cloud, and the other complexities that comes with it. Or you don't want to do the app service environment as well. You don't want to build up an app service environment and deploy your logic apps into that. But you still want to use logic app as your integration platform. So you can go for a container platform, right? And the other reason would be the security. Like you want full control of your logic app. You want to run it in your place, your choice of locations, your choice of compute and everything. Right? And the last point would be like, you are actually running multi-cloud in your organization, and you have like few of the very, very important services actually running on Google or AWS, and you want to use logic app to integrate them. And you did not have an option before. If you want to natively connect to it, like now you can deploy your logic apps into those multi-cloud scenarios, multi-cloud platforms, and you can actually start integrating your applications there. So all of your workloads and all of your assets are there in that cloud platform as well, right? So that's the why. Now that actually we got the why out of the place, we can move to how. How can we actually do the containerization of logic app, right? So with the there's a lot of work going on, and there's a lot of improvements on the logic app. So currently, as of now, what you can do is actually you can develop your logic app locally, like both the varieties of logic app. You can develop your consumption plan, multi-tenant logic app, or your single tenant standard logic app from Visual Studio Code. And you can run it anywhere. Like you can deploy it into your local machine on a container, or you can deploy it into a container platform like managed by Kubernetes, or you can deploy it into like Google Cloud or AWS Cloud or OpenShift container platform anywhere. And the last part is actually, while you're doing that, while you actually have all of your workloads available in those remote Kubernetes platform, you can still manage it from Azure. You can actually connect your Kubernetes cluster to Azure, and you can manage it from Azure. And there is a lot of benefits, there are a lot of controls that Azure provides, like the traditional problems or traditional overheads of actually managing and running a container platform. Few of those options are actually available in Azure itself. Like, so you can do a lot of those effectively from Azure itself. So let's look at how you can actually do the containerization, like from the scratch, right? Like how can you actually build a container, and how can you actually run it locally and see like the developer experience a little bit. I don't want to actually go into creating a logic app from scratch. I can show you a logic app which is already built here. It's a very simple logic app. So this is Visual Studio Code, as you know, and from the Visual Studio Code, actually, with a little with few extensions installed, you're able to deploy, you're able to develop logic app with Visual Studio Code. And so when you connect your Azure as well to the Visual Studio Code, you have the option to create logic app standard, and you have the option to create logic apps consumption. So here I have obviously created a logic app standard logic app, and when you create it, you get for each of the workflows, you get a separate folder, and within the folder you get a workflow.json file. This is where all your code actually is saved, and this is your designer view. As you can see from my designer view, it is a very simple logic app. It actually receives a HTTP request for this is a weather API, and if you say my city is Wellington, and it's going to call a weather API, and it's going to give you the response back. And so it's a very simple API. It's let's see how you can actually containerize it, and you can run it locally and run it on Kubernetes, right? So once you have all your logic app is completed, if you think that actually your development is completed, you need to be adding a Docker file. So Docker file can be added from you can actually manually add it, or you can actually say run this command to add a Docker file to your solution. So when you run this command, this Docker file will be getting added. And that will be without any environment variable. But you can add your environment variables here. Like, I've added this environment variable because Logic App needs a backend, like a little bit of a data storage for to store your running instances and like to show you the last run instance and what happened and like at each stages and run histories and everything. So it needs a storage account, and here I'm using an Azure storage account. Instead of the Azure storage account, you can actually use all of these other storages with the recent announcement. Actually, there is a private preview going on. Apart from using a storage emulator, which is actually a local, which enables you to like locally develop your Logic App. Without a storage account, you can actually run a storage emulator and connect to it, and you can run it locally on the Visual Studio Code, and you can debug it and everything. And there is a service called Azurite. Azurite also let you do the same. Or you can actually add a storage account like I'm doing right now. And in addition to all of these options, you can connect all of these varieties of SQL servers as well as a backend. You can do SQL Server on premises or SQL servers on a VM, and you can actually run a SQL server on a container and connect to it and make that as a backend for your Azure Logic App. And you can also connect the two varieties of the Azure SQL instance as well, the regular SQL and the managed instance SQL. I've actually tested the SQL, like local SQL and the Azure SQL and the SQL running on the container. It's working perfectly fine. So for this example, I'll be using the storage account. So that is one of the environment variable. The other three environment variables here are actually to say, like, what is my website host name and the website name itself and the function and like Azure function environment, development environment. So if I actually want to containerize that regular Docker command to say like Docker build and what is my tag. I'm going to change that tag to demo, and that's going to build my build an image. That built an image and run the Docker run command with that image. I might be having Docker running already on the same port. Let's give it a minute and let that release the port. Oh,
You have another one running there.
Which is running on port 8080.
Mm-hmm.
that actually I just killed it.
No, you're killing recursive
Oh, right,
Einstein,
okay.
but you're not killing Charlie Nightingale.
I killed the SQL database rather than the actual Logic App. Okay,
There we go. No containers running.
so that's the nerves actually. Right. So I wanted to delete the Logic App container. I deleted the SQL container by mistake. Anyways, it takes a bit of time to spin it up, and it actually goes through and does the whole startup process. And right, so when you see application started on and the listening on the port here, you can actually understand that actually this is the startup is completed. And if you go to the secrets, let's see. So what that means is actually like when the logic app is actually logic app starts up locally, so you have an option to go and get the callback URL. So how you get the callback URL is actually go overview here. Oh, sorry, this is on a container. It didn't create a secret for me. Right.
What is the
What it's
instance that you
supposed to,
have created there?
like it didn't create a secret file for me. That's an issue. It's like if I go here under the logs, it didn't actually. So what it's supposed to do is actually it's supposed to go in and create a couple of files for me here, like a log file here and a secret folder here with the name of the image I have given. So, all right, okay, because I'd like to change this to,
Logic app demo.
yeah.
Mhm.
Let me kill this instance. I'll remove this instance because the name is actually a problem because there is a folder already there and it didn't actually overwrite the folder. Right, so this means actually I need to go through the build process. To run this again. Hopefully this time when it runs and brings it up, it has to create a log kind of folder for me, secret folder. Okay. This time, yeah. So because actually I had a name, I had a folder already created here. It didn't overwrite the folder. So now I have a secret folder. Within the folder, you get a host.json file. And if you open the host.json file, you can see a master secret. So this is the secret I'll be using to do the to list the callback URL. So what I have to do is actually there is a certain endpoint, like management endpoint for this particular logic app to list the callback URL. This is not the real callback URL, but I need to get the callback URL which is deployed into the container. Right. So if I actually replace the code with the new code I got, and if you inspect the URL itself, it is a management URL, which is like which goes like after your localhost port, runtime / webhook / workflow / and then actually if you see here, this will be your workflow's name, and then the list callback URL, which is the structure of this logic app URL. And if you send it, it actually gives you a response with a secret in it. This is the whole URL if you want to call the logic app directly. But since you're running locally, it is not running on HTTPS, and it's not running on 443. So what I do is actually I have the same kind of structure here, and change the signature to the new signature. I should be getting the other details back. Right, so this is actually hitting the logic app that is hosted in the container platform here. So how do I know? Like, so the logs here, like when you see it, so it actually says that actually this particular get weather by state function is actually programmatically called via the host API, and it gives you the whole details about each and every action, like how you can see from the logic app, a regular logic app that is deployed onto your Azure portal, how you can see the run history. You can see the whole detail here as a log. But you still don't have that management facility where you can see the run history in a proper graphical way, right? So yeah, this is how actually you containerize your logic app, and like now actually you have an image built, right? You have the image built, and so it is actually like for any other development platform or for any other areas. Now that you have the image, if you want to deploy that workload into any of the Kubernetes platform, that is the same kind of principle now. It's the same process where actually you create the manifest and you create all the files that are required for that. And then actually you either deploy it using a CI/CD pipeline, or you actually go into the particular Kubernetes platform and deploy it from there. It is the traditional process lifecycle for this image now. So this image is actually a very lightweight function image. If you see that actually it is actually a function 3.0 image, right? So going back to the presentation. So now it can be run anywhere. Now you have an image built, and that image can be deployed into like now what we did actually, like it deployed into a Docker container. If you want to go for a small scale implementation, you can actually go something like that. Or if you want to actually bump it up and go to a properly managed Kubernetes container platform, you can choose OpenShift or Google Kubernetes Engine, or AWS's options, or like Forget, or the other Kubernetes option there, and the OpenShift option. Any kind of Kubernetes platform, you can run this workload, right? So what I actually did was I chose Google Kubernetes Engine, because like why not, right? You can actually deploy it anywhere. So I've tested it in Google Kubernetes Engine on AWS as well, Forget as well. It actually works, but what I can't do right now is actually I can't run each of those commands and let you guys wait. So what I did was actually I have something already running, and I will show you how it is running, and I will show you what are the steps that needs to be done in order to make it work, right? So this is the Google Cloud Platform, and as you can see, actually under Kubernetes Engine cluster, I have 2 clusters. So for deploying it directly into the Kubernetes engine, I've used this cluster 1. Right. So if I before actually deploying any workloads into this cluster, I need to actually bring that image we just built into the container registry. So I have this image, the same image, the get weather by state logic app image uploaded into the container registry here. And once I have the image uploaded to the container registry, I actually can deploy that workload as a workload into the Kubernetes cluster here. So if you see under the workloads, if I choose only the cluster one, I'll be able to see logic app that is deployed as a workload here. I call it weather direct because I'm deploying it directly into the Kubernetes engine. I just wanted to show you a different deployment option as well. You can deploy directly into any Kubernetes platform, or you can deploy it from Azure itself. So this is just to show I actually have deployed it directly into Google Kubernetes engine. So this is a workload that is actually deployed. Like if you want to see the experience of deploying it, you can actually go through the deploy, and you can select the image from the image existing in your container registry. I've chosen this, and that is my image. And you can keep it basic, or you can keep it very advanced, right? And you can also actually provide a name here and choose a namespace, and then actually you can choose which cluster you want to deploy that into. When you actually do that, you get a workload deployed, and once all the pods actually got deployed and everything is actually ready to serve, you get a status OK. And when status OK come, like under this, actually you have a couple of options. Like you can actually still edit the workload, and you can see the logs here, like how that like what are the logs actually that particular application is producing. You can see the logs, and you will see the similar kind of logs actually, like when it starts up, whatever you have seen in the whatever you've seen here, you can see the similar kind of logs in here as well, right? And you can find the definitions of that particular workload here, and here I've not set up the DevOps pipelines at all to deploy it. It's all actually manual, but you can set it up in Azure DevOps or any other DevOps pipeline platform. Right. So once you have the workload, how do you access this workload from externally? Right. How do you actually call this logic app? Right. So you need to actually expose this workload as a service, and then actually you need to create an ingress for it, so that we have a public. Like if you want to call it like outside from the public, if you want to do it, do the workload accessing everything internally, there's other ways actually. Like now I want to access this workload from outside, from externally, right? So if I want to do that, I have to expose that as a service. And when I actually do that, actually I do the port mapping. Like, you know, I want to actually access it from 443. My target port is actually because it is running on 80, and my protocol is TCP. And I want to, like, if I want to actually expose it externally, I would have to go for load balancer type, right? So once I expose it, I will have a service here. Service will be created, and it will have an endpoint ready for that. But I need to create an ingress for this in order for me to be able to access this logic app and, you know, access all the functionalities that I have implemented within that logic app. So what I can do is actually, like, I selected service, and I can create an ingress, and the ingress also actually gives you a bit of a very easy way. Like, you know, you can select the backend, and you can actually configure the front end. Like, how do you want to access it? Whether you want to access it via HTTP or HTTPS. If you want to use HTTPS, you want to configure the certificates and everything. So once you've done it, the ingress will be created, and the ingress will be will have a public IP. All right. So this is like, at this stage, you have exposed your logic app, which is deployed into Google Kubernetes engine, to public. So if I actually access this, you see this, like, you know, so it's a very familiar page, right? your function app is actually up and running. So this is a very familiar page. Like when you deploy an app service into an app service plan, you can actually see this page from there, right? So it is actually up and running, and I can actually access it. So another thing is actually when it gets successfully deployed, you get the same kind of behavior where you get a lock created. You get a lock created. Like these are the locks because 3 pods are running for me for that particular logic app, and 3 of those locks got created, and I get a secret file created as well. So this was a secret file that was created for me. And if I wait for it to load it, and if I get the master key there, accessing it actually is the similar process. You have to get the callback URL first. And I have, like, if you see here, my host is the same host as the ingress here. And it follows the same URL pattern. And all I have to do is actually, I just need to change my code. I think it's the same code. And if I send it, I'll get my callback URL. Once I have the callback URL, I can go and call that with the new secret. Application failed. So if the secret's not right, it's gonna fail. There is a supposed to work, but it's it's pretty wild. Okay. There is actually like if the key is wrong, if the secret's wrong, the security mechanism is actually working fine. If you look at it. Okay. Right. Okay. I think there was a small gap of expired signature there. It's misbehaving. Okay, but you got the idea, right? That is, so the service is actually deployed into Google, and it is actually responding, and it's saying actually my token's wrong. Go see if there is anything useful here in the logs. It says it succeeded. I'm not getting a response here. Let's see if I can get another token. It's not moving fast. It was working. So this is the classic. It was working before symptom. Anyways, I don't want to actually get stuck into it. Okay, moving on. So, okay, so yes, you are able to containerize your logic app, and you are able to deploy it into any of the container platform. And so what else? What else actually Azure is actually offering? What's going on? So Azure is actually Azure has introduced this Azure Arc service a while back, and it is actually adding the supported Arc connected supported services quite a bit. The list is actually increasing. The latest additions to the Azure Arc are actually app services, function app, logic apps, API management, and even grid. What that means is actually all of these services can also be containerized like this and deployed into like any of the Kubernetes, or you can deploy it into Azure itself, Azure Kubernetes service itself, or you can deploy it into on-premises or AWS, GCP. Like I said, like all of these services can now be deployed into any of the container platform, but you can still manage it from Azure. So what that means, like the whole life cycle is actually like you can develop all of these services from Visual Studio Code or any of the IDEs, and you can like deploy all of those services using any of the any of the DevOps tools, like GitHub Actions or Azure DevOps pipelines and things like that. You can deploy that into any of the Kubernetes platform, and you can use application insights or log analytics to monitor those workloads. Right. So those are the things that, like, if you're deploying the workloads directly onto any Kubernetes platform, those are the things actually you may need to do it by yourself, and those are not very easy work to do. Right. There are there might be additional third-party services involved and things like that. But with Azure Arc, actually, you can use the application insights and log analytics. Maybe your existing investment itself, actually, you can use that to monitor that. And you can manage those resources using Azure CLI, or you can use Azure resource management templates, or you can manage it from the portal itself. And then actually you can once you have all these services available and deployed and everything, you can govern those services using regular Azure policies and regular Azure security implementations, and what are the HA and DR implementations that you want. We can all actually do that from Azure Arc, actually. Okay, so what does that mean to me? Like as a developer, what does that mean to me? I'll be actually starting my lifecycle on Visual Studio Code, and I'll be doing all my coding on Visual Studio and using GitHub Actions or Azure DevOps to do the deployment on the build pipeline, release pipeline, and all of these services like Azure Web Apps and Function App and Logic Apps, and even grid and API management. All of those services can actually be deployed into any of these Kubernetes platform, or you can do it on the Azure platform itself directly. Right. Personally, I would actually go for the PaaS option all the time. Right. So most of the time, actually, when you have to deploy like a very small scale implementation, and depends on the other factors, actually you choose to go for PaaS services first, and then actually if your organization is very mature on the Kubernetes platform, and if you have a strong case for the Kubernetes, like containerizing your workloads, and sometimes actually the security and the other factors, like keeping all your workloads together and keeping all your workloads into your on-premises investment itself, you would actually go for the Kubernetes option. So that is your life cycle as an app developer, and as a IT, the admins and IT other people, they will be actually doing the governance of the Azure application you are deploying. Like any of the investments, like any of the Kubernetes platform or any of the infrastructure you're going for, you can actually use Azure policies and Azure security controls and all the other features that are provided by Azure by using the Azure Arc. Right? And what do you need to do? What do you need to do in order for you to be able to manage your workloads that are available externally, like somewhere else? Like you have your logic app deployed into your Kubernetes cluster hosted onto your on-premises, but you want to manage that from Azure using Azure Arc. How do you get there? What are the steps that you need to do so that actually you can connect to it and you can actually manage it, right? So there is something called Arc-enabled Kubernetes cluster. So that's where you start with. So your Kubernetes cluster needs to be connected to Azure Arc. You enable the Arc onto the Kubernetes cluster, whatever the Kubernetes cluster you are targeting it, and then create that as a custom location for you. What that means is, what custom location means for you is actually, if you are familiar with the any PaaS services creation in any of the cloud providers, when you actually start with the initial form would actually ask you to go and pick a location, like whether you want to deploy it into an Australian region or European region or any US regions. Those regions are actually the locations, right? But if you enable like Arc onto your Kubernetes cluster from your Azure or Azure portal, when you actually create any of the PaaS services, so those enabled services, you can choose this Kubernetes cluster as a custom location for you, rather than choosing Australia or like Australia East or Australia Southeast. You can choose this Kubernetes cluster as your location, so that at the end of the process, at the end of that filling that form, when you click create, that service will be created within your Kubernetes cluster. All right. So once you have that custom location created, you move on and create an app service environment. Like if you are deploying Logic App and Web App and Function App, you create an app service Kubernetes environment within Azure. That construct of an app service Kubernetes environment will be created. Within that, you are able to create app service plan and Web App or Function App or Logic App or like all of those services. So from there, from the Kubernetes environment, your experience is actually similar with other Azure services, like like the regular way of creating app service plans. Like if you wanna deploy Function App in the regular Azure world, you will be creating an app service plan, and you'll be deploying your Function App into it, unless you're going for consumption plan. Even with the consumption plan, there will be an app service plan created for you, right? So from after this, creating your Kubernetes environment, the experience is similar. You create an app service plan, and your web app or function app or logic app is created. At the moment, it looks like actually when you create a web app or function app or logic app, you will get an app service plan created dedicated for that particular thing. You can't the regular Azure experience, you can't create a single app service plan and host multiple function apps into it and things like that. You can't do that. It seems like actually any like if you're creating a web app onto this environment, you will be having a dedicated app service plan created for you, right? I'll show you the services that I had to create in order to make this Arc thingy working, right? So, like I said previously, you need to connect your Kubernetes cluster to Azure Arc. So this is where actually it happened. So with this, this is a no-cost management construct service that is created within Azure. And this actually is actually going to tell you what is the infrastructure that is connected to this Arc. If you see that, one other thing actually before going into that is, as your Arc is still in preview, it is not it is recommended to production with a lot of additional warnings and things like that. It is not recommended to production at the moment. And it is available in West Europe and the US East region only at the moment. Yeah, got that out of the way. And from this overview, you can see that the Arc GKE, this is a Azure Arc service for Kubernetes that is connecting to my Google Kubernetes engine on the GCP infrastructure. And my Kubernetes version is actually 1.19.10. That is, so I am actually connected to my Google Kubernetes engine from here. How you can verify that from the other area is that actually, so I have a cluster here, Logic Apps on GCP that is created here. So this cluster is actually connected to the Azure Arc. And to verify that, what happened was actually when I connected to it, I got these basic, like apart from the so once the connection is successful, you will get these pods getting created within the Kubernetes cluster you are trying to connect to. So these are the basic pods that gets created, and that actually enables the connectivity of your Kubernetes cluster from Azure. All right, so this is, once these all are up, you would get the connected status here. So that means actually both are in sync. You're able to connect, you're able to manage that Kubernetes cluster from here. So that means, like, what that specifically means is actually you can deploy the workloads from here. It is the very first step of the fundamental like foundation that you need to do. You have to connect to it, and then actually you have to build on top of it. Right. So from here, actually, you see the experience is actually very, very like similar to any other services. You can actually do configure the Azure policies here, and you can do GitOps integrations to that, and you can actually enable application insights and log analytics integrations and everything. And you can also like connect it to the security center as well. And the regular IAM options are available for you here. And so once you have this connector, the next step is actually to add an extension to that connector. You have like multiple options here. Like, you can actually do you can deploy API management gateway onto your Kubernetes cluster. So if you want to do that, you add this extension to it, right? If you want to deploy Event Grid onto your Kubernetes, you add this extension to it. Or if you want to do web app or function app or logic app to it, you add application services extension, right? I've already added application service extension. So what that actually means is it actually creates another sets of pods into your Kubernetes cluster. So going back to my Kubernetes cluster, if I include that namespace, all right, so. Okay, so these are the pods that gets created to manage the workloads that we are going to deploy as app services. Right, so these are like, if you actually are very familiar with Kubernetes, I'm not, but if you're very familiar with Kubernetes, actually you can actually get into all of these pods, and you can see what each of those pods are doing very specifically. So one thing I specifically noticed is actually whenever you deploy a new application, a new logic app or function app, this gets restarted, and this actually kind of adds the new applications into the log processor, so that actually all your logs are actually properly processed and things like that. That is the kind of experience I have noticed. So going back to the Azure Arc, okay, so now I got my app service extensions created. What does that mean? What do I need to do next? So now I have my Kubernetes cluster connected, and I have installed my app service environment, kind of like app service abstracts and concepts into the Kubernetes cluster. So now I need to create this Kubernetes cluster as a custom location. Right, so this is my custom location. So what that actually means is now you can actually use this custom location when you create a new logic app service. I'll show you shortly. And once you have the custom location created, you will be creating an app service Kubernetes environment. App service Kubernetes environment actually is deployed onto that custom location, and you will get a domain name assigned. I think actually this is the domain you will be using for your like as a host for your like whatever the application you're deploying into it. right? So if you see that actually, what are the applications, like how many apps and app service plans I have deployed into these app service Kubernetes environment, you can see it here. I have like 2 app service plans and 2 apps created into this app services Kubernetes environment, right? Once you have all these things set up, you're now ready to deploy logic apps, function apps, web apps from here, like you do regularly. Like, let me show you that experience. Logic app, standard, create. So I choose my resource group and I choose standard and I give a name. And you have 2 publishing options here. One is actually like you can deploy the code itself, or you can deploy the Docker container here, right? If you want to deploy the code, you get all the options, all of the location options, and also the custom location. So I choose the custom location here. Right. I thought actually this was also not going to work for me. Right. So storage account, obviously for Logic App, there is a storage account that is required. Currently, only storage account is actually supported. No SQL experience here so far. And monitoring, you can attach an application insights to it. I have an application insights created already. And once you add the necessary tags and stuff, and you're able to click create, and it takes a bit of a time. But in the meantime, I will show you whatever is already deployed here. You see I have 2 logic apps deployed here. Now, GKE Docker. I've deployed a Docker image. I have deployed VS like from the VS Code as well. 2 logic apps I have already deployed here. So it's a similar experience. You get the same kind of application created from whatever, like when you deploy it from here, the same name service will be deployed into your actual Kubernetes cluster. So what that means is actually you are just controlling the experience. All right, here. So I actually have my logic app created. And it's going to take a bit of a time to get the pods like stood up and come to the OK stage. But the idea here is your deployment is complete. And this logic app is not deployed into Azure. It is deployed into your Kubernetes cluster, but you can manage it from here. You can look at your monitoring and performance, and you can like configure deployment slots, and you can do these network securities as well. Like, you can enable SSLs and custom domains, and all authentication. Like MSA authentication is not available at the moment, but you can do the classic authentication where you create a AD application and use that as a authentication. And also, actually, you can configure health check here. And the other thing is actually, like, if you are deploying any schemas and maps, you can see it from here. And because actually you wanted to deploy that as a code, you can deploy, like you can configure the automated deployment from here itself using the deployment center. You can select any of the path. So I have my GitHub actually configured. So I can select my repository where my code is. And if I save this, my continuous deployment from the code is actually set up. I can manage that experience also from here, right? Or if you wanna deploy a logic app using Docker, choose my resource group and it's standard. I say Docker demo, and if I choose Docker, I will get only my custom location as the region. I will not get any other region available for me. And the rest of the experience is same. I choose my storage. I choose my AI and tags and review plus create. And when I create it, so in the same way, actually, what's going to happen is I'm going to have a new workload created for me. So my other things actually, the code deployment logic app is actually successfully running now. If I have some code deployed into it, I can access it. If you see this experience I told you before, like, any new application that gets deployed, this log processor actually gets recycled and restarted. And I think actually behind the scene, it's actually adding the new application into the log processor so it can collect the logs properly. And the next one's now it's going Docker demo. All right. So if I go back to my Azure Arc side, if I go to that resource, I have the similar kind of experience. I can do health check. I can do check my metrics from application insights, configure deployment slots, and rest of the stuff. And most importantly, I can do deployment center configuration as well. I can go and configure, like, container type. I can do a single container or Docker compose. For now, actually, I will do a single container. I have this source option as well. Like, you can choose from a container registry or like other pipeline options. And if I choose container registry, I will get this experience. Like, from the registry source, I can choose these three. So I have a Azure container already running for me with few images. So if I choose that, and I can make that as a continuous deployment as well. Anytime actually the latest tag gets updated, it can actually run for me. So if I do the save, so when I actually deploy it from an image, what's going to happen is actually this is going to recycle the existing application and create a new instance for me. New instance of the same application with the actual image also deployed into it. Yeah, so on all replicas pending termination because there is a new deployment that is actually coming with the same name. So it actually terminate the old replica and actually add the new application with the new the image we are deploying. Right. So that is the experience from the Arc. So you can even the same kind of thing for the function app as well. You can choose my custom location here. You can do the code deployment or the Docker container deployment or anything. For the same goes for the web app as well. So with this extension, actually I get all three options. And if I add the within, like if you remember, within my connected Arc connected cluster, if I add the extension of API management gateway or even grid on Kubernetes, I will be able to deploy an API management gateway to the Kubernetes cluster, and I will be able to deploy even grid onto a Kubernetes cluster. All right. So that's the management experience that Arc provides for you. And going back to which is already done. Right. So then we are moving on to the last segment. What should you be doing and what can you do on top of this experience? You should definitely be looking at best practices for image tagging and versioning properly. You can either go like semantic versioning, or you can do the pipeline assignment of the versioning properly, like the automation of the versioning there. You should be really looking into the. So initially, the session was going to focus on all of these as well, but I actually realized it's going to be very long. So what we can do is actually like maybe in the future we can have a session that is actually now that actually we are familiar and we got the background of the containers, logic app on containers. Now, like the next session can be focused on the advanced concepts, like, okay, once you have your logic app deployed into the container, what else can you do? What else do you have to do in order for keeping that workload onto your container platform managed properly, right? So you have to do the secrets management properly, and you have to do the monitoring, like application insights. It's doing the monitoring, okay, but you have to do the proper overarching kind of monitoring solutions, and you have to obviously automate the deployment, whatever the options available, Azure DevOps pipelines or the GitHub option, like actions pipelines and things like that. Then you have to obviously implement mechanisms to do continuous improvement of your workloads that are deployed into the container platform, right? That actually brings us to the end of the presentation. Thanks a lot for listening to it.
Thank you, Vinnie. And if I understood correctly, you volunteer yourself to another session really soon.
Yeah, exactly.
And hopefully no lockdown next time.
Yes. So let me see. If anyone has any questions, I didn't see anything on the comments, right? But if anyone has any questions, just like raise your hand and open your microphone. And in the meantime, I think you can stop sharing your screen, Vinnie.
Oh yeah, sure.
Otherwise, you're going to have like the Inception thing going on.
Right.
So, any questions? One question that Craig had is how much of the Arc Enable stuff is GA versus how much is still in preview? Do you know?
Like most of these services so far I've read is actually in preview, and it's available only in Europe and US East, not in any other region. So all of the services actually, like one of the problem I heard was actually initially when I started trying to connect to a Kubernetes cluster, actually created everything in Australia East. That is my habit, right? That is the habit, like, and it wouldn't connect. It wouldn't actually like give me proper errands and things like that. And I was like, why? Why is it? Where am I going wrong? And then when I went back, and it said actually these services are only available in West Europe and US East. So you have to deploy these services only in that area. Yeah.
Okay. So Kubernetes cluster seems to be GA, but custom locations is still in preview. Looking at the Azure Arc Kubernetes cluster here. But the custom location was core for everything that you're doing, right? Because that is actually is how you're creating that your own region.
Oh yeah, yeah. So one of the other things, actually, if you don't mind, I just wanted to show you that is the cost of this, right? Because your workloads are actually, am I presenting?
Yes.
Okay, because your workloads are actually deployed into the Kubernetes cluster. The cost of those services running is actually very, very like non-existent to very minimal. Like it's going to take a bit of a time to load. So one of the challenge I faced was my credits ran out. So I had to create a Azure account with my wife's student email. So I get a student sponsorship. And so that with that, actually, I got $100. And I thought actually it was going to run off because I've been working on these samples for like last 1 week. And I thought it was going to run off before the presentation, but come on. It actually, so far, for the last 1 week, all these services that ran, I actually was charged $1. And most of them are actually for Azure storage account. That's what actually I wanted to show you, but it is taking a bit of a time. It actually gives you the particulars of all the services that are actually charged. Cost is very, very minimal because your workloads are actually being deployed into, yeah, here. I spent $0.54 so far, and those are actually on storage and log analytics. Yeah.
Do you think that'll change once it comes out of preview?
I'm not sure. I think
I don't think so, because I think the main idea of that is is actually be able to manage your workloads and then have the connectivity, having the one pane of glass being Azure, because then you kind of that's like the lock-in that you have is like one pane of glass is Azure, and then everything else that you're using that is not Kubernetes based, the first thing they're going to think about is using best services. Yeah, so I don't think it would be the case for that changing too much in terms of price. Usually what I saw before was the pricing being like 50% discounted when it was in preview. So even if it's like 50% discounted, I would still be like a good price.
Fair enough. Sounds good.
Any other questions? Audience? No, doesn't seem like have anything. So Vinnie, thank you very much for your time. Yeah, like I'll do. Let's do the virtual clap, yeah. And we're going to get in touch to get like that next session organized. So see if we can finally fulfill the in-person in Wellington.
Oh yeah, sure, definitely.
Thanks everyone for joining. I'm going to be like just trimming that down the very beginning, and I should be publishing that tomorrow. As soon as I have that published on YouTube, I'll let you know, so you can review or share with your friends or anything.
Cool.
Great.
Thanks, Vinnie.
Thanks a lot, everyone.
Yeah.
You're welcome, man, and thank you for your time. So
Cheers,
Thanks,
Vinnie.
Nathan.
Thanks, Vinnie.
Thanks, Nathan. Thanks for joining.
Cheers, Vinnie.
All good, mate. Good to see you.